Morning, everyone. Thanks for everyone's time again. Obviously, we've got a couple of topics to go through with the Nova guys, and then I'm going to jump on and do a few more bits and pieces. And yeah, take notes for the exam. I'll be reviewing the exam questions again after today's session, making a few little additions. I can't make it too easy for everyone. And then I'll send out the link and today's notes and all that later on today. And you'll have a couple of days to do the exam before we pull the link down. But yeah, any questions, by all means, chuck them in the chat, and the guys from Nova will start this thing off shortly.
Hi, hello. Good morning, everyone. This is Roy from NovaStar. And today we will keep talk about troubleshooting. And the first part is screen flickering. And before the training of this part, I hope that we can think about the question. The first one is when we have a problem with our display, what is the first question we have to figure out? And the second one is, if there is no video source and it's not convenient to connect to the computer, how can I quick check whether the component can work normally? And for these two questions, we can move to next page. I think for the first question, the most important part is that we should find out where the problem comes from. The positioning problem is a key to solve the issue. The problems is happening whether in controller side, including video source, controller, HDMI cable, or in receiving card side include Ethernet cable, screen power, modules, and receiving cards. And the screen control function will help you locate the problem. About the second question, if the control system cannot provide a basic source, for example, different color, maybe it's very convenient. Screen control can do that. So first part is a screen control and test 2. We would say operating the screen control function shows the color from receiving card directly. For instance, if your LED has a color cost problem, so you can use screen control function to display color. If the problem processed, then the problem comes from the receiving card side. If the problem disappears, then the problem comes from sending card side. So this function is quite useful in the first place to start troubleshooting. And let's take a look at how to operate this function. There is an icon of screen control on the main interface of NovaLCT. And the click screen control, there are some options like blackout, freezing, and normal. Also, you could select self-test to display the different color and the test content. And sometimes on-site environmental does not allow us to connect software to operate. So don't worry, we can also use the screen control function on the front panel of the controller. Taking mControl4K as an example, press the knob from the main interface, we can select the display control. And the functions will be very similar as them in software. Another useful function is test2, which displays some color pattern on computer, so on LED screen too. Test2 function is quite helpful when we need to check if LED is displaying pixel to pixel, and also we locate some abnormal components or modules in the center of LED screen. So here, we can see another icon in the main interface that is test2. And also if you are logging in, click here and the test2 is here. Step 1 is to build a window with same resolution of LED display in test2 function. We need to set the start coordinate and the pixel width and height. Normally the window starts from 0, 0, just normally, yeah. And here is a grid test function in test2, helping us to identify the screen display states if there are some tearing lines in LED display. And the next part is test2 will be orientation. We only need to tap the voice component resolution and the module amount per component. Then the display will separate the whole screen into several modules, easy to find the broken module or component location. So as a conclusion, the screen control and the test2 can be the first step to do the troubleshooting. They will help us to locate the problem in which side and which module. After tools we need, we will say screen flickering issue now. And now we can see the screen is finished. And if we want to show the image, we need to build the basic structure of the LED control system. And here we can see the control computer. The control computer is connected to the sending card through a USB cable or a network cable. Then the sending card is connected to the LED display through network cable from different output ports. And regarding the display, it's composed of many components. This is the basic structure of the whole LED control system. That's the receiving card, hardboard, and the flat cable to LED module. So what is a possible reason could cause the flickering issue? Let's say, that's how it could be the possible reason. That's receiving card, sending card, Ethernet cable ports, power supply, video source, flat cable, firmware, hardboard, video cable and the interface, RCFGX fail, module hardware, or the PC or laptop issue. So how can we locate the issue more accurately? And the first and the most important point is that Is the flickering fixed on the screen or not? Okay, we can see the first part is if the flickering is fixed. If the issue position is fixed, we can see 3 different situations that flickering happens on a specific output port of the SIM card, or maybe flickering happens on a specific component, or maybe flickering happens on a specific module. Okay, so for first one, it's happened on a specific output port. We can try to exchange with another output port. And if the problem stays on the same old output port, that might be a SIM card output port issue. So if not, if a problem switch to the new output port, that should be the Ethernet cable issue. So for second one, the flickering happens on a specific component. So we need to check the firmware and the receiving card parameter. Is that same with other normal receiving card? The receiving card parameter, that's actually RCFGX file. So if that's different, that's not same, we can make it same with other receiving card and make sure all of them is same in software part. And then we can exchange the issue receiving card with a normal one. If the problem follow the receiving card, that's a receiving card issue. If not, if the problem stays on same component, that's a component hardware issue. So we need to check the module hardware or the hardboard. Okay, third part is if the flickering happens on a specific module. We need to check the flat cable, hardboard socket, and all of them for the issue solved. And we will list all the situation we will face maybe in the future and also the solution for that. The first part is for a specific output port of the SIM card. If that's an output issue, that might be the first component power fault. So we need to change the power supply. And if the output port is overloading, so that means the total pixel resolution is over capacity. So we need to just change the structure in our software. And also for Ethernet cable, the Ethernet cable of that output port is bad connector. So maybe just change the cable, yeah. And for the flickering happened on a specific component, first part is a check power supply. And if that's not good, change power supply unit. And if that's an Ethernet cable issue, and we can try reconnect or just change. And if the issue happening in the receiving card part, that might be wrong RCFGX file, wrong firmware. So for RCFGX file, we need to read from a normal one and send it to this receiving card. And if that's a firmware issue, just upgrade to the correct firmware. And if that's a hardware issue, means receiving card fault, we need to change a new one. Yeah, and the last part about the hardboard. The hardboard fault, the solution is also change a new one. And if the flickering on a specific module, we need to check the power supply. If that's module power fault, change the power supply unit, or maybe just a power cable. And if that's a hardboard issue, that's a hardboard connector fault. So just change to other connectors or change new hardboard. And the last part, if we are using the flat cable, it's a flat cable bad connect, that's reconnect or just change. So all of this is about the flickering position. It's fixed. So next part, let us see if the flickering is unfixed. Yeah, the issue position is unfixed. And then we got two situations. That's whole screen flickering or screen randomly flickering. Okay, so both of them we are using screen control, send the test pattern to the screen. And if the problem on the screen side, we need to check the screen power supply, firmware upgrade, load the original RCFGX file or make a new one. Here, if you cannot do that by yourself, maybe just contact screen supplier or maybe contact NovaStar. Yeah, and if the problem is not on the screen side, we can check the sending card part about the sending card, video source, video cable, or Ethernet cable. And all of them just for solve this issue. And also we have list of them here. That's a phenomena. It's full screen flickering or random flickering. So the potential cause for the computer side might be the graphic card output issue. So we need to change another graphic card or PC. And another one is about the software setting part. That's if the graphic card frame rate is not matched with sending card. Normally, if you are set the graphic card output frame rate to 50 Hertz, but normally our receiving card are set it as 60 Hertz, so we need to set the same frame rate on both sides. Okay, and one more is a video cable. For video cable, that's just a connect damage or loose. We need to change a new one. And the sending card part, about sending card part, that's a input interface damage, or maybe Ethernet output issue, or maybe hardware issue. But all of these three, we need to replace a new sending card. And for receiving card part, that's a wrong RCFGX file or wrong firmware. Yeah, so what we can do is send the original file or create a new one or upgrade the firmware to correct one. And the last part is about power supply. So just change or repair the power supply. Yeah, but normally, if you follow the this way to do the troubleshooting, I believe we can fix 99% screen flickering. But if you still need help, we are very happy to help. Please just contact NovaStar, or maybe just contact Nathan. Okay, so first part about the flickering issue. It's finished, and we got a 3 minutes break.
Hey guys, I know guys, I got one more little topic to cover off, and I'm going to jump in and do my little thing. But yeah, just stand by. Obviously, keep writing your notes down for the exam. The more I think about it, the more harder questions I'm thinking about putting in there just to test you all. So you know, got to keep you on your toes. But I'll hand back to Ray.
Okay, so let's start second part. After that, I will show you the troubleshooting about different brightness issue. And we also have a question and answer time after my presentation. Okay, let's start. Okay, first we can see the phenomenon here, that is different brightness. Might in one side or in single combinate or some combinates for this side and combinates, yeah. And here we have listed the possible reason for different brightness. And the first one is a different brightness mode. We all know we can choose Grayscale mode and the contrast mode. That's two different. So maybe we have put different model in different combinates. And the second one is a different RCFG file. And the second one is for the receiving card. They have loaded different firmware. Same combinates with different firmware. And the fourth is calibration coefficient. That means maybe some combinates have open the calibration coefficient and some are not. And the fifth, that's a hardware part, maybe the power supply. The power supply with different output, that means different voltage or different current. And the last reason might be the multiple batch, means the screen with multiple batch modules. And as we know, the brightness information is always saved in the receiving card. So we manually adjust the brightness first to make sure the receiving card is under the same brightness level. Then we select one of working mode to make sure they work under the same working mode. Then we just send and save it to hardware. And for reason 2, that's different RCFG file on the screen. Different RCFG file, the parameter is a little bit different, and it may affect the brightness efficiency. So what we have to do, just read back the correct RCFG-X file from normal receiving card and send it to those abnormal receiving card. We can see here, we can select which receiving card we are trying to read, just count which port and which receiving card is that. And when we say that, we can click this specific receiving card and select the position and send. Okay, so the third reason, that's same combinates with different firmware. The different firmware may also cause different brightness issue. Sorry, because the structure, the instruction in different firmware may different. So we need to find the correct firmware. You can check with your screen supplier or NovaStar, and we can try to help you find the cross-binding firmware version, especially if that's a customer. If that is a customer, the firmware, then just upgrade the correct firmware to the receiving card, which have different brightness. And we all know, I think the first day, we all know how to upgrade the firmware, yeah. And the first reason, some combinate has opened the calibration coefficient, some are not. do you still remember that the calibration coefficient is saved in the receiving card? So it could be that some of the components enable the calibration effect, some are not. So we can manually to enable the calibration again. And because of a lot of reasons, maybe this receiving card lost its calibration coefficient, or the receiving card is new replacement, or receiving card did not open calibration. So what we need to try is first to turn on all the calibration, and if that not work, maybe we need to re-upload coefficient database. If you don't have the database, then you need to recalibrate it all the way with a camera or with a NovaLCT and adjust coefficient function. And for this part, we can see more details in following video. You can find that in our web. That's novastar.tech, support and training, and the NovaStar online workshop. Because to upload or maybe do calibration by yourself, that's not an easy work. So maybe check the specific video. They will show you that step by step. And for the hardware part, sometimes the issue may not come from the control system part, such as the power supply. Check the power supply if it's normal for our components. If not, we may need to replace to another power unit. Sometimes the power supply output is not strong when cause the LED not have enough drive current. And the components of one, maybe of part on the screen showing different brightness with others. So what we can do, just test the voltage of power supply output, whether it's correct, and how can we know the value of correct voltage for power supply? Maybe for this part, just need to check with your LED supplier or maybe the LED manufacturer. And the last possible reason is if the screen is from different batch, then it is for sure that you have different brightness. It is hard to fix this different batch issue. So, but we can try to improve the screen effect with a multi-batch adjustment function, multi-batch adjustment function, or with adjust coefficient function. Now we can say in our software tools and the multi-batch adjustment. And if you do not understand what is a multiple batch, that means the lamp or the modules manufacturing at different time. So the LED lamp has a different wavelengths and brightness, will cause the screen looks different. We can improve the effect, but cannot totally solve it. And for this multi-batch adjustment, you can also find out in our web. Yeah, NovaStar.tech. It's also support and training and online workshop. And if you have checked all of these reasons, I believe the problem will be solved. And also, if still have this issue, just contact us. And let's have a simple review about this part, about different brightness. That's first, check different brightness mode. And for software part, also RCF GX field, different firmware, and the calibration coefficient. And for the hardware part, that should be the power supply and the multiple batches. So that's all about the different brightness part. If you have any questions, just leave that. I think we will answer after that.
Well, thank you very much, Jay, for that little chat that you just had, going through those few little things. If I can possibly share my screen, we'll do Q&A at the end after I do my little bit. So just keep popping those questions in the group chat, and we can go from there. Cool. So let me share my screen so we can look at another PowerPoint, which is just what we all love doing. Stand by. I'll just click some buttons because that's what I'm going to do. Here we go. Okie dokie. So look, a few more little things that I'm going to cover off today. Carrying on from yesterday, I've added a couple of extra topics. The guys just covered a few little things on the brightness. I'll go into a little bit more detail, but then you've also got those online videos on the Nova site that can give you, once again, more in-depth detail about this. First thing I'll cover is edge correction. So basically what happens here is you guys, a lot of the rental guys, or realistically any LED screens that you put up, sometimes a millimeter in the alignment or adjustment of the screen can cause some issues with some bright or dark lines. As you can see the picture on the left there, you can faintly see the line versus the one on the right. And if you basically zoom in a bit closer, this is what's causing it. It's basically the LEDs are getting closer together. So what do you do to fix it? Well, fundamentally, the software will go in and adjust the brightness of those LEDs to compensate them being closer or further apart to make it look seamless. To do that, just open up the software, go to Tools, quickly adjust bright dark lines, and then you've got two options there. You've got to quickly adjust, and you've also got a new version on the right, which is much better, but it's only going to work on the newest series of receiver cards. So if you've got an older screen, you're going to need to use a common version versus the newer screen, the newer version on the other one. The newer version is much prettier and much easier to use, but for this demonstration here, I'm going to show the common version. So most of you out there with current screens are probably using the common version. And there is no reason that you can't use this version for both either. So once you go into this, basically what will happen, there'll be a couple of things that are going to happen. As soon as you go into this, your screen's going to look all whack and weird, because what it does, it ramps the gamma right up so you can really see how bad your screen's looking. The other thing it's going to do, and the ideal way to do this is have the PC that you're working on plugged into the screen and set it to be a secondary output. So basically that grey square that's appearing on this is the secondary output. And in this quickly adjust bright or dark line screen, you can see an option there that's got main screen or backup screen. So you can actually shuffle that rectangle onto the secondary screen. One of the other things you need to be cautious of if you're running Windows, or even, well, only run on Windows, is to make sure that you haven't got any desktop scaling turned on, because by default now on the laptops and Windows will change the scaling to be higher than 100% to make it look nice. One thing with this, you need to ensure that your desktop scaling is set to 100%, otherwise it's not going to line up properly. But once you've done those two things, in essence, this grey square should match the exact pixel spacing of your screen. And once you do that, you'll basically get this option here that'll show the cabinet sizes on your screen. Now, there's also an option if you want to do individual modules. You can click up the top here and pump in the module size. You'll need to manually do this and calculate it from your panels. You should know how many pixels are on your screen, how many modules, and you can do the simple mathematics there. But fundamentally, you then just click on the sections that you want to adjust, whether it's the corners, tops, bottoms. You can select the whole screen, you can hold down control, select different portions. You've got various options there. And then it's simply down the bottom, you can do a white priority, you can do certain colors, and you just adjust it up or down a little bit to suit what you need it to do, and pretty much hit save to hardware. If you've got some stubborn pixels, you can actually double click on the edge there and you can bring up the individual pixels around an edge as well. So look, that's a very quick overview of the bright dark lines, but it's really not that hard. Don't be scared to use it, but the thing that will bone you if you're not careful is that the whole video lineup thing. Look, you don't need to run it that way. You can just run it blind and pick where your lines are and look at your screen mapping and do it. But if you want to get really finicky about it, then yeah, I suggest you do plug your control PC into the same source, do an extended desktop, and go and adjust the lines that way. If you want more detail on this, there's plenty of videos online on how to do this, or reach out to me and I'm more than happy to help. Moving on, I'm going to start talking about receiving cards just a little bit, and predominantly around the new version of the receiving card, so the Armor series, which is, look, they're the new standards. They're it's sort of, you know, most of the major manufacturers now, not that there's many left doing sending and receiving cards using this format now, which is basically the little dim type here that's on the left. But yeah, so basically, look, this is the standard range of the Armor series that Nova are running. I know all the screens that we spit out at ViewPix are running Armor series now. And they've been very solid, as is the whole Nova range. The failure rate on these is almost non-existent. Predominantly for us, I know on our screens, most of our screens are running A5S. The premium versions are running A8S, and then we got some of our fine pitch stuff running the A10S Plus. Look, each card has its benefits, and I suppose you need to ask what you want when you're ordering your screen. Look, the A8S has some great features. It obviously supports, you can see the tick boxes there. Clear-view, which just cleans up some text when it's fine resolution and the text isn't over pixels. It's pretty detailed. It sort of works. The A8S also supports free rotation. You need the Nova R5 receiver to do that, or the Ultra HD Pro, the big one. It'll also do free rotation. And they also support the low latency. Same with the A6. So when you're running low latency mode on certain sending cards, you can get your frame loss down to about 1 frame from in to out of your processor. So it's pretty good. But once again, you do pay a bit more for these options, and you need to look at your use case scenario as to whether it's something that you want. As I said, our premium range of cabinets do support, you know, we run A8S in our premium range. Obviously, better grayscale as well on the higher screens. And that 22-bit basically means it supports HDR to a point there. And all the other features there are pretty standard. Across the whole Armor series range, you can read back the firmware, you can do file restore. One thing that's standard across the Armor range as well, obviously the A8S and the 10 does free rotation, but the whole standard range will actually do 90-degree rotation, in increments of 90 degree. I'll show that in a sec, as well as mapping. So the Armor series will show that mapping information on your screen when you're configuring it, when you tick that enable mapping box in the software. So look, basically to do the rotation, if you go on your receiving card page, first thing you always want to do is read back your receiving card file to make sure you're right. But if you hit that set rotation button there, you'll see you get options to do a 90, 0, 90, 180 or 270-degree rotation of your cabinet. So that's just a handy little feature that the Armor series does do for those of you that are running Armor series. If you're not sure what card you're running, you can always jump into the firmware version and have a look. Alternatively, on the newer versions of Nova, it will actually appear down the bottom of this screen here when you read back what version of firmware and hardware you're running there. So look, that's sort of a very quick overview of receiver cards. Obviously, there's a lot of legacy receiver cards out there, MRV 220s, 320s, 460s. Look, there's nothing wrong with them. It's just like everything. There's newer versions of things coming out. They work. And yes, all the Armor cards do the 90-degree rotation. So if you are running Armor series, you can get that 90-degree rotation stuff. I'm going to talk a little bit now about the brightness stuff, which we just covered. I'm just sort of going to talk a little bit more, not so much about finding issues, but just some features of this screen, I guess. You've got priorities here for contrast and grayscale. Once again, that was more for legacy style of screens, where some of the older screens were prioritizing when they had the cheaper ICs, I guess you could say. They prioritize what their performance were on the ICs. With a lot of the newer screens, it's not too much of an issue, but hey, it's still an option that's there. Some other features here, obviously, you can click the color temperature button there, and it'll give you a rough warm. It'll give you a rough white balance. Once again, you can calibrate it with a normal colorimeter if you want to, or you can use your eye. As everyone seems to have their own preferences, what they call white. And also, if you've got custom gamma files for your screen, which are normally factory supplied, you can load them in there. Your gamma adjust, look, it depends on your screen and your LED chips and all that sort of stuff. It normally hovers around 2.4 to 2.8. If you don't know what I'm talking about, put some dark content on your screen and play with your gamma value, and you'll see what happens to the blacks in it. Basically, it'll crunch them, or it'll, yeah, have a bit of a play with that with your screen. Normally, as I said, it's normally factory set, but there might be an option there that you want to go and tweak some things. Another little handy feature is if you go under settings and advanced color. There's two parts to this screen, and once again, it depends. Some screens won't let you change the current gain, some will, but this is a really quick way to just try and color match ultimately different sources, different screens. And this is another quick way if you've got two different batches and you're trying to tweak them. The easiest, I use this when I'm doing multi-batches. If I've got a customer that's got different batches, I will basically build the whole screen, but I'll run one batch on one port, the other batch on the other port, and configure that accordingly as two screens in the screen connection. And then I'll come in here and adjust one screen to match the other. Yeah, it's a bit of stuffing around, but look, you're never going to get LED screens to batch exactly, and I'll talk a little bit more about that shortly in the calibration section. But this is the sort of quickest way to try and get them close. And another little thing that you can do in here as well, if you're running outdoor screens indoors, obviously, as you know, you need to ramp your brightness all the way down to get them to be nice. If you come into this section here and drop your current gain right down, what that'll basically do is make your ICs not work quite as hard, but still give you your full brightness control. So where you might be running your outdoor screens at 20% inside, if you come in here and drop your current gain down, it means you can crank that brightness potentially back up to 60, 70%. And it's just going to give you that grayscale stuff in the middle that you want that's nice, rather than the screen only having 10% of its brightness to play with to get your full image. It's back up to 60, 70%. So that's a handy little feature if you're running outdoor screens inside, just to come in and drop your current gain right down, and it'll give you that better color. Try and not have another coughing fit today, guys. So yeah, look, that's just some tips around the color stuff. Once again, if you want some more features, just a shout out. And yes, Mike, I know. Moving on to calibration. Now, this is something that I get asked a lot. People are like, oh, if I get a calibration kit and pointed at my two different batches, is it going to fix it? No, it's not. What calibration will fix is issues like this. Basically where, look, it's the same batch, but it's just not looking that pretty, and it could be a combination of masks. It could be a few different things, and as you can see there, it's just not. It's not pretty. So calibration will fix up stuff like that. So I'm just clicking here. So as you can see, look, modules are made up of LEDs, simply, red, green, and blue. As we all know, SMD chips are like this. The old DIP had 3 colors, but they were just bigger chips. And that's what they look like. What happens with LEDs? Well, look, the human eye's got a bit of tolerance between what some people consider red and other people consider red are sometimes a little bit different. And the biggest issue that happens with LED screens is batching. Fundamentally, the way that the LEDs are made from a variety of chemical mixes and processes, they're each a little bit different. And when they're made in different batches, they come out with a slight variance, and that variance can be up to 30%. So sometimes when you've got different batch screens, the red and green might look fine and the blue is completely different. You can't change that tinge of blue. It's just the nature of it. And calibration isn't going to fix it. It's going to make a difference, but it's not going to fix it. So, you know, whenever I say to people, oh, I'm going to buy a screen now, I'm going to buy another one in 6 months and run them together, it's never going to look the same. The other thing you've got to factor, especially for your outdoor screens, is you've got issues like masks that you can get some UV damage. The masks also come from different batches as well. So they may look a slight different tinge of grey in comparison to the one next to it. So there's all sorts of issues that come down to batching. Whenever I say to people, if you're going to buy a screen, try and buy as much as you can or you think you're going to need. And if you're going to buy another screen, then try not to run it side by side. It might be the same pitch, but you could potentially have color issues. I know with our factory, we try and color match things to the best, but we're never going to guarantee 100% color accuracy between that. And another thing that changes as well is obviously the driver ICs. A little fluctuation in voltage here, or even a driver IC that might be discontinued between two versions of a screen can have big issues in the performance and the color of the screen. So it's not just the LEDs, it's also the driver ICs. It's less likely your driver IC is going to go end of line than your batch of LEDs, but look, it does happen. And it's just a matter of looking once again at the exact performance. So you can see here, this one here is plus or minus 1.5%. Not much, but overall it can have an impact. And once again, this comes down to the quality of the screen, the type of the ICs. The macro block, the MBI ICs are a lot more, I suppose, resistant and a lot more batched, whereas you get some of the cheaper ones, they may not have these tolerances. So, you know, once again, you get what you pay for with LED screens, and that's why there's massive price difference in products on the market. Something else to look at as well is different wavelengths with the LEDs. So, you know, you can see here different batches do different things. And it's just the nature of LED, unfortunately. And ideally, this is what LED should look like. They should be all uniform in that. But sometimes you'll get that, which is going to make your screen look a little bit funny, or you could also get a complete variance in color. So that's some of the things that happen with LED screens to make them look different. And the other thing that happens as well is different masks. As I said, like that, you can see there, it's really hard to tell on the screens, but that will happen with screens as well. You'll get different masks, different shading. Even though the LEDs could match, they could have different masks. So there's a whole combination of things that will cause screens not to work that well. So the question is, what can we do to fix it? We can calibrate it. So that there is what I call a batched screen, but it just needs calibrating. So you can see all the little module edges. You can see this. You can see it doesn't look great. I'm sure it's in its worst case scenario being all white, but that's uncalibrated, and that's the same screen calibrated. So you can see that it just uniforms everything out. What it does do though is it actually drops the light output of the screen. So before it was running at 1,000 nits, but what the calibration process does is basically drop the luminosity down to be the brightest of the lowest LED and sort of flattens everything out around that to make it work. You know, that's what the calibration process does in a nutshell, and that's why you'll see some spec sheets that come out 5,500 nits as a peak brightness and calibrated at 5,000. So that's at 500 nits that it's doing to do this calibration process. And this way, you know, once again, it comes back to the quality of the LEDs and the consistency in the binning. All our screens that we make, we're all batched to order. So, you know, you order a 50 panel screen, we'll order enough LEDs for 60 panels, keep some in stock and spares. And that's the way it goes, where some of the cheaper ones, they'll basically just grab whatever LEDs they can from the same manufacturer and then do a calibration process on them. So look, each to their own, but that's, you know, that's how some manufacturers can produce things a lot cheaper than others. It's all about the quality. So yeah, that's just talking about that. Once again, you've also got, you can adjust some green point. You can change what you consider white balance as well in this stuff. So it's just a matter of going in and defining these points. This can all be done in the advanced color part of the software. The way that it's done is with the NovaCLB software. There's two ways you can do it. You can either use Canon 70D. There's a couple of cameras supported, or you can buy the proper Nova calibration camera. Now, guys, this stuff isn't cheap. I'm not going to lie. The dongle just for the software, if you're using your own camera, is sitting around. Don't quote me on this. Garth in New Zealand is probably going to shoot me. I think it's about $5,000 or $6,000 just for the dongle. And then on top of that, you need the camera. And realistically, if you're going to be doing fine pitch stuff, you want to get a proper Nova camera. It's good for stuff, you know, around that 2 mil and under. So just be mindful. And that camera kit with the dongle and all that, you're looking around $50,000, $60,000. Some of the competitors, other people other than Nova, their calibration kits on the market are hovering around the $100,000, $150,000. So, you know, if you're going to get into the calibration game, it's a fairly substantial investment. And it's also, it's not the quickest thing as well. If you're going to calibrate a screen every time you put it up, you're still looking, even for a 1080p screen, if everything's set up perfectly in the way you go, you're still looking at an hour to do a HD screen. So it's not something you just magically rock up to a gig 10 minutes before the door and go, oh, I'm going to quickly calibrate this screen. It's not really for that. That's not what it's designed. I'll often calibrate fixed installation screens if they need it once they're installed, but you really need to ask the question, does it need calibrating? Because it is a process, and normally screens are factory calibrated as well. But once again, put it up, have a look at it. If it's looking nasty, it probably needs a calibration. It may or may not fix it, but yeah. But look, this is the software here. It looks nice and friendly and easy to use. From experience, once it's set up, like I'll stuff around with the camera for probably 40 minutes just to get it lined up right before I even start the calibration process. So it's not, look, it's easy in a way, but you've got to know what you're doing. So yeah, as I said, Nova got some online videos on this, and we're happy to help where we can, but it's not a 5-second job to do screen calibration. So the easy things to do that you can play with, as I said, are the bright dark lines, the advanced color stuff, doing the batching over different ports. But yeah, if you want a proper screen calibration, obviously we here at ULA, we've got a kit. And yeah, we can have a chat about this offline if anyone was interested in some kits. But yeah, so that's sort of it for calibration. As I said, there's a whole nother, I could spend hours talking about calibration. I won't bore you all, but there is a lot to it. So yeah, and also you can always push back on your manufacturer to say, I want everything calibrated before it leaves the factory, and they should be able to offer that. I know in our factory we got 2 massive big boxes that basically by NovaStar, they're about $2 million each, and they'll do a calibration of a cabinet in about a minute. But that's what they're designed for doing calibration at a factory level, which is what's happened to all our panels here at VPix. Not that I'm doing a plug for them. Moving on to other stuff with Nova. I'm going to talk about the function card. Some of you may or may not know about this little card that basically you can either get in the box form or you can get in the card form. It'll support light sensors, and it's got an audio output as well. So if you're doing a fixed installation and you've got HDMI audio that's embedded, you can use this card to spit audio at some speakers at the other end that are powered or something. Is it great? Look, the audio stuff's okay, but what this card is good for is brightness sensors. So fundamentally, I'll put any fixed installation, I'll have one of these cards with a brightness sensor plugged into it. As you can see, the card version itself has has some extra ports in that. And you've also got relay control that you can ultimately use for anything. Inside the software, you've got this button that says, if you click on the function card button, you can go in there and you can do all sorts of things. It's also where you set your light sensor up, which is the main use that I use for the function cards. Once you're in there, if you've got the light sensor plugged in the port 1, hit save, you get a lux reading, and then you can go into the brightness setting and use the automatic brightness sensor settings, and that's how that's triggered. If you are running the function box and an appropriate sending card, it'll work, and fundamentally the brightness stuff will function without the need for a control PC. If you're doing the brightness scheduling with a time, you're going to need a control PC if you're doing time scheduling. But if you just have to use the automatic sensor, you can plug the function box straight into a sender card. It'll sit there all day long, do brightness up and down to a heart's content. As you can see here, 256 levels of brightness. Some of the sensor cards, as I said yesterday, have the brightness sensor port in the back of them, or you can have the multifunction card. And from a control point of view, it just sits in line with your normal screen signals. So it just plugs in part of the chain. It's got an Ethernet in and out, and away it goes. Or you can just plug it in a spare port you've got on your sender. It doesn't matter. It just comes back to that function card setting on the front page of the Nova thing. You tell it what port it's attached to, and away you go. There is also a temperature sensor that you can get that will give you ambient temperature readings. It's more the feedback to the Nova software, just to, if you want to spit it up on your screen as a warm fuzzy if it's a fixed install. I haven't sold one of these to date yet, but hey, they're there. Because predominantly now you can pull weather information relative online and feed it RSS feed or do something like that. So look, there's a couple of sensors that you can get, but yeah, fundamentally I sell a brightness sensor with any of my fixed outdoor screens, even some indoor ones. It's just an easy way to adjust the brightness. And even some of you guys that do live events, you could always mount one of these in a little box and sit it somewhere side stage, so at least when the sun sets, you don't need to worry about changing your brightness on your screen. It'll just do itself as it gets darker. One of the other little boxes that we've got, I did touch on it yesterday talking about the fiber extensions. You need to be cautious with what you use for Nova screens. These are obviously the Nova certified boxes. There are some other aftermarket ones that will do it. Just bear in mind, while it's saying it's Ethernet, it's not IP Ethernet. And a lot of the fiber converter boxes out there will treat this data as IP data, try and convert it and spit it out, and it won't work. So Nova, the screens are running their own proprietary format. It's still an Ethernet packet. It's just not an IP packet or a traditional data packet as per se. So that's why some of the other fiber converters out there won't work. And that's why these ones are here. They obviously come in two models, a multi-mode and single mode. And yeah, that's it. They've also got a rack mount version there, as you can see down the bottom, which is just a smaller thing. And they'll come in ways of 4, 6, 8 or 16 way option. So you can put one of them at your rack end and then break out the other boxes at the other end. And they're just with a little LC connector and standard multi or single mode fiber. Steve, for the brightness sensor, look, the maximum length they recommend is 15 meters into the function card, and then obviously you're back to normal Ethernet protocols on that as well. The other kit that you can get for fiber extensions, also the CVTK 4S. So fundamentally, this is a 4K fiber extender. This will work with the R5 or the M-Control 4K. So if you're running this with the R5, you're only going to get utilization of half of this. And this is also, incidentally, the H series as well. You can also pump out to this as well. So yeah, you can run this in full redundant mode with the 4K. If you've only got a pair, you can run 8 ports off a single fiber. That's it in a nutshell. So then you've got backup and main, so hence the 4 ports for the 4K. So you've got some redundancy there. Obviously the R5's only got 8 ports, so you've got a backup and main. That's it for the fiber on that. The 660 Pro, even though it has fiber, it won't talk to this box. It will only talk to itself. So you need a 660 Pro at each end if you're going to use one of those fiber boxes. So look, that's it for the Nova accessories. So yeah, any questions around that stuff, by all means, just chuck them in the chat and we'll get to it. This stuff's more around the fixed installation, but it's also handy for those people with rental screens if they just want a quick look to see what's going on. And there's 3 sort of tiers that you get with the monitoring solution. Now, to access this stuff, it's just simply hitting the monitoring tab on the front screen. But basically, it's just using an underlying serial chain under the feed that's going to the screen. So what you might notice sometimes, if you're monitoring large screens, you may get some false errors. So if you do a refresh, they'll disappear. And that's just to do with the amount of data that's just getting pushed over the network and some packets getting lost. It's not a major issue. Some people freak out when they see an issue of a card, but it's like you refresh it, it goes away. As I say to people, also have a look at the screen. If there's a fault on the screen, then there's a fault. If it's just monitoring fault, just refresh it, it'll normally go away. But basically that's in a nutshell the way the receiving cards work. And the standard thing, which most of you guys are going to have with your basic things, if you click on that monitoring tab, you'll get a sending card, you'll get DVI, and you'll know whether or not you've got redundancy. And then the next step up is if you get a monitoring card added to that panel. So there is a monitoring card. It's mainly at the bigger cabinets because once again, it's taking up more space, and this is more a fixed installation thing. Some of the features that this will give you, in addition, depending once again how it's configured, it'll do extra things like tell if you've got a faulty ribbon cable, the door's open, all the stuff that's mentioned there. So there's definitely some extra features there. And there is another feature up, and this comes down to having certain ICs, certain LED modules. You can actually get LED error detection as well. Once again, that's all at a manufacturer level, talking, making sure it's got the right components to talk back to the monitoring card to then feed the information back into the software. So yeah, it's just a matter of how you want to do that and how much level you want on your cards. As I said, most of the normal rental cabinets have that. Some of our high-end cabinets have the monitoring cards in them. Do I get a benefit out of it personally? Debatable. Like realistically, you just want to know whether your cabinet's working, whether you're getting data to it, and whether you got redundant feed. As I said, so you get the basic solution with every receiver card, you're going to get that. The advanced solution, you're going to get some humidity, a few extra bits and pieces. And then if you go the individual error detection, as I said, you need some special type of ICs in your modules that feed back to your monitoring card. And there's also other customized solutions that can be worked out with your manufacturer, but normally they're the sort of standard sort of things that you get there. So only some might have it. This is just a quick picture of how the monitor card on the right works. You can also see the big white thing in the middle there. That's actually a smoke detector to pick up smoke. But I know here in Australia, you get a lot of false positives of that because of the high humidity that we get. So I find the smoke detector isn't really viable either. But it's there, it's an option. But as you can see here, the way that this ribbon card works across two models. So once again, it's all dependent a lot on the manufacturer when you're getting down to this nitty-gritty stuff with the monitoring. As far as it comes down in the software, if you hit that monitoring tab, you'll see in here, this is an example of two senders with a redundant link between ports 1. So green's primary, 2's the backup, and you can see there it's got a link between 1 and 2. And everything else down the bottom is green. If you've got a redundant link error, you're going to get a green, you're going to get a red X on that line, and it'll basically say, okay, I've got an issue with redundancy. It's still working, I've still got the panels up, but I do have an issue on that redundancy. Also there, the reason, if basically that's saying sending card 2 also doesn't have a video source at the moment. So that yellow, green is good, yellow is bad. So looking at that, sender card 1 is green, it's got good video, and it's also got good backup link to port 1 of sending card number 2. However, there's no video source on sender card 2, so if it does fall over, it's not going to work. So that's the difference between red and yellow, green and yellow in those couple of windows there. The other thing to look at, obviously, as I was saying, you could occasionally get some false positives. Even though that's looking like it's not working, if you refresh a few times, it might come good. But fundamentally, if it does still stay red, then you've got an issue with it. And you just need to go and assess what's going on with it. And normally, as we said, some of the issues we had could be a bad receiver card, could be power, could be numerous things. You just need to go and assess what it potentially could be. The other thing that you can do as well is obviously you have brightness settings, temperature settings here. In the monitoring configuration button there on the right, you can actually go in and set some parameters. If the screen hits a certain temperature, it'll drop down brightness and do all other things. So that's an option there if you want to run this. Bear in mind, for all of this stuff to work, you're going to need to have a control PC connected to the sender, either via Ethernet or USB at all times, running the Nova software for some of these advanced features to work. On top of this, there's a whole Nova iCare stuff for the fixed installation market, where you can basically cloud monitor all of this stuff as well. So that was going to be, I was going to touch on that when I do this another session on the whole Taurus range and talk about Vnox and the cloud platform and iCare and all that sort of stuff. So for those that don't know, the Taurus platform, it's more for fixed install again, but it's basically a little box. It's an all-in-one box. that will basically media player, all-in-one, cloud service, monitoring, 4-port sending card in it. So yeah, they're a nice little box designed for fixed install. And once again, those that know about the product know what I'm talking about. If not, feel free to jump on the Nova site and have a look or shoot me some questions. But yeah, predominantly targeted at an installation screen. You wouldn't really use a Taurus box for a rental style of product. But look, guys, that's I've covered a bucket load of information there, and I've sort of raced through it. So if you've got any questions or anything about that, Rail, what's the ideal temperature a screen should have? How long's a piece of string? Look, the receiving cards, that temperature that the monitoring shows up is reading basically the temperature of the receiving card. It's not reading the ambient temperature. It's not doing anything other than looking at the temperature of the receiving card. Now, the receiving cards are good up to about 70 or 80 degrees, but you wouldn't want to run them that long at that sort of temperature. So yeah, it just depends, you know. Ideally, you want a normal screen should be hovering about 30, 40 degrees. But if you've got a screen that's, yeah, under 50 is good. But it depends. If you've got a screen that's copying direct sunlight in an afternoon on the back of it, cooking your receiver cards, yeah, you could get up to 60, 70 degrees. Far from ideal. So you just need to look at each of the environments and see. But the cooler your components run is always the better. Obviously, I've been to the Nova factory. I've seen the way they stress test everything. They basically run their cards with content in an oven to see how much stress they can take. And we do the same in our factory as well. We'll burn everything in. You go to the back of the screens, you can't touch them, they're that hot. So look, they can run hot, but it's always going to shorten the life of your electronics if you're cooking things. As I said, if there's any other questions, by all means, chuck them in the group chat. In relation to the exam, I'll finalise a couple more questions and I'll send out the link. I'll try and get it out today. If not, it'll be tomorrow morning. So I'll send out the 2 PowerPoints that I've done the last 2 days, today's video, and also a link to the exam. So yeah, hopefully you'll all pass. If you fail, I'll be disappointed. No, it's okay. Basically, it's a multi-choice and some true and false sort of questions. So it's not, yeah, it shouldn't be rocket science if you paid attention to what we've covered over the last few days. So there's a few questions in the group chat about some SFPs. We'll answer them in the Q&A when it comes out because it's a bit detailed. But fundamentally, if you just stick with the Nova boxes for fiber transmissions and use the SFP supplied, it's the easiest way to do it. If nobody's got any other questions, we'll probably call it a day, and I'll send out the links to everything else as soon as I get them all finalised. You're very quiet, which is good. It's okay, everyone. I hope you all got some information out of this. Basically, the test is online. You'll get notified you'll get notified on the spot when you hit the submit button at the end whether you've passed or failed, and it'll all go in Nova. You'll basically then get entered into the Nova training database, and you'll get the certification emailed out to you that way. The pass is 70%, I think it is, on the pass rate in the exam. But yeah, it's not rocket science, guys. If you've all got half a brain, you should be able to pass this thing. As I said, I'll send the link out for the test in my next email with everything, and you can take it online at your leisure in the next couple of days.